today we are going to start CMA English medium with quantitative methods for business subject. So here I would like to give a brief introduction about the subject, and it will be helpful for you to easily pass the exam. This subject has mainly six chapters. The first one is basic mathematics for business. Here, it should be under basic mathematics for business. What we do, we discuss basic mathematics knowledge we should have to do calculations. Right? Probably most of the things you will know, but here we will do this because this will be the foundation of business mathematics subject. So after that, we will discuss about frequency distribution and presentation of data. So under that chapter, what we will discuss is how we are going to present a data. So we actually collect data. After that, how we are going to present it. For example, graphs. There are a lot of different types of graphs. There are bar charts, there are pie charts. Even in bar charts, there are the percentage bar charts, or else you can have presentation the percentage bar charts, or sometimes the multi-bar chart. So at that chapter, we will discuss how to select the best best chart based on your requirement. So after that, we will be discussing about probability and sampling theory. How we are going to do the sampling and calculate some probabilities. After that, we will discuss statistical inference. After that, we will discuss about statistical inference. Statistical inference means how we are going to conclude some certain things that we found from the sample about the population. That is what we call statistical inference. After that, the fifth chapter is relationship techniques. So under relationship techniques, what we are going to discuss is how to measure the relationship between two variables. How to measure the relationship between two variables, and that will be discussed under relationship techniques. So how to, and what kind of justification we can give uh, for the relationship of two variables. The final chapter is Introduction to Financial Mathematics. That is the most important chapter under this subject, which will be helpful for you when you do accounting sometimes, right? So how to calculate simple interest in simple interest, and after that compound interest, and the annuities, present value, future value, and NPV, net present value, internal rate of return. Those kind of things will be discussed under Introduction to Financial Mathematics the chapter. So those are the six chapters we are planning to cover before you sit for the exam. And in your exam, you have MCQ questions. You will receive MCQ questions, and it is online examination. And in a way that will be easy. In a way that will be easy because you have some answers. So from that, you can pick one correct answer from the available answers. So that is how you are going to sit. That is how you are going to learn about this qualitative methods for business subject. So my approach is I will do some calculations, and I will try to explain as much as possible for you to grab these concepts, right? And at the end of the each a chapter, I will share a note. At the end of the each chapter, I will share a note which you can refer. You can take a printout of it and you can use it. And I highly recommend when I write something on my whiteboard or when I tell something, you take a notes. You take your own notes because that is important. You take your own notes. If you couldn't get something, you better to refer my note and fill the gaps. So don't wait till I give my notes because I will give at the end of the chapter. Right, I will give it at the end of the chapter, and I will give some more questions because when you do mathematics, most important thing is you have to do calculations. You have to work hard to achieve your goals. That is the only success formula for mathematics. You have to work hard, right? So that is a brief introduction about the subject, and I will give a brief introduction about me as well. I'm Shaman Fernando Fulle, who graduated from University of Colombo. I specialized in financial mathematics. I specialize in financial mathematics. I am a member of Certified Management Accountants of Sri Lanka. I am a member of CMA, and I have completed my MBA as well. And at the moment, I have 6 years of experience in a reputed insurance company in Sri Lanka as right in the executive grade. And I have, when it comes to my teaching experience, I have 3 years of teaching experience for a professional examination. So I only do lectures for a AAT, CMA, CA, and IBSL, all for professional classes, professional courses, and business mathematics and statistic subject. So I hope you got some idea about the subject and you got some idea about your the lecturer. And now we will go to start the lesson. Fundamental question is, I will give a very simple example. How can you get the number like this? What is the answer for this calculation? So as you see, you can think of calculating this in many ways, right? Sometimes you can say it is 60, or sometimes you can say it is 30. Or what is the answer? What is the answer? So what you can do is you 5 plus 3, 8. 8 to the power 2, 16. Or else 2 into 5, answer is 10. 10 plus 3, 30. So what is the correct answer? Now, that is the confusion most of you may have at the moment. But to clarify this, there is a method which is introduced by a mathematician, and we call that method is BODMAS. The method we call as BODMAS. So here, what you can do is this BODMAS says which type of calculation or which the mathematical function you need to do first, right? So when I write it like this, B means bracket. B means bracket. O means off. D means division. M means multiplication. A means addition. S means subtraction. Right? S means subtraction, right? S means subtraction. So this is the way you need to get the answer for this kind of equation. That means you have to do the calculation of brackets first. If there are some brackets, you have to do it first. After that, off. And this one we do not use much. Offs we usually don't use much. And after that, division, multiplication. So these two can be interchanged, right? These two can be interchanged, no problem. You can do multiplication first and after that division, or you can do the division first and do the multiplication next. It can be interchanged, and after that, addition and subtraction. These two also can be interchanged. So, what is the answer for this? According to board math, you have to do multiplication first. 2 into 5, 10. Plus 3, the answer is 13. Answer is 13 because you have to follow both maths if there is something like this kind of thing. We'll do some examples. What is the answer for this? What is the answer for this? You can take 1 minute or 30 seconds and say what is the answer, or you can try it by your own. So what is the answer for this? First, as I said, you have to do multiplication and division. First, multiplication and division. 2 into 3, 6 plus. And after that, you can't add this 5 to 6. You can't add this 5 to 6. You have to do this multiplication. 5 into 4, 20. Divide by 2 minus 3. Then, after that, we have to do this division. 6, 20 divided by 2, 10 minus 3. Answer is 30. This is an example how you can apply what mark concept. How you can apply both mass concept. What is the answer for this? Example. 5 plus 3 inside the bracket. Multiplication, multiply by 2 minus 2, 4 into 6 divided by 3. What is the answer? Take 30 seconds and try to get the correct answer. Right. We'll try. First, you have to solve the brackets. 5 plus 3, 8. 3 into 3 by 3. After that, you have to do multiplication and division. 8 into 2, 16 minus 4 into 6 divided by 3. What is the answer? 8. Now we have to do the subtraction. Answer is 8. So this is how you need to apply the BODMAS concept when you do when you solve and when you use mathematical operations. So these we call mathematical operations: addition, subtraction, multiplication, and division. We call mathematical operations or mathematical operators, right? Mathematical operators. So after that, what we are going to discuss is the classification of numbers. Right? Now, after that, what we are going to discuss is number systems, how we classify numbers. First one. Whole number. What does it mean by whole numbers? Whole numbers also we call it as counting numbers. We call this as counting numbers as well. So those are positive integers, right? Positive integers we call as these counting numbers or whole numbers. Whole numbers are positive integers called as whole number. Positive integers. For example, 2, 4, 5, 8, 10, 11. Likewise, these are whole numbers. Right? These we call as whole number. So after that, we are going to discuss another a set of numbers we call as integer numbers. Integer numbers means positive or negative. So negative numbers including positive or negative numbers including 0 called as integer numbers. Positive or negative numbers including 0 we call as integer numbers. For example, -3, -5, 0, 8, 4, 8, 7, 6. So whole numbers are subset of integer numbers. Whole numbers are a subset of integer numbers. Whole numbers are subset of integer numbers. So I hope you have a good idea about this and this. So this is first we discussed about whole numbers. Whole numbers means counting numbers like 1, 2, 3, 4, 5 likewise. And integer numbers means positive or negative numbers including 0. And these are also not here we don't consider the decimals, right? When you say integer, no decimals, right? When you say integer, no decimals, but minus any value without decimals and positive any value without decimals into and 0. After that, we are going to discuss about rational numbers. Rational numbers. After that, if any number can written as P over Q where Q not equal to 0, then that number is called as rational number, right? It is very simple. Rational number means if any number, if any number can be written as P over Q, where Q does not equal to 0, then that number is called as rational number. For example, 8 over 3 is a rational number. 9 over 5 a rational number. Then what about, so now you may think that is there any number which cannot be written as this? Is there any number which cannot be written as this? Yes, there are numbers you can't write as this, right? So those numbers we call as irrational numbers. Those numbers we call as irrational numbers, right? If there is a number which can't be written as this, irrational numbers, if there is a number, is a number which can't be written as P over Q, then it is called as irrational number. For example, square root of 3. What is the value of square root of 3? Square root of 3, if you take that value from the calculator, the square root of 3 is 1.7325050808. Likewise, this goes infinity until infinity. So that means you can't write this number as P over Q. You can't find a P and Q which is equal to this. So this kind of numbers we call it as irrational numbers. Square root of 3, square root of 5, square root of 8, square root of 7, any the majority, for example, square root of 25. Square root of 25 is equal to 5, okay? Square root of 25 is equal to 5, but square root of 7 may not be, you can't write like this. So these numbers we call as irrational numbers. And other example is 5. Called as 5. What is value of this? This value is 3.14 something. And you can't write this pi as P over Q. You can't write as P over Q. We approximate 5 as 22 over 7. That is an approximation. That is not the exact value. Therefore, it should be like this. This is the sign of approximation. This is a sign of approximation. We say that 5 is approximately equal to 22 over 7, but that does not equal to 22 over 7. So this is what we call irrational numbers. So after that, we will be discussing about real numbers. For simple, this is real numbers are the combination of this is the set of real numbers. This is combination of rational and irrational. So real numbers are the combination of rational numbers and irrational numbers. So now you may think, are there any numbers which belong to which does not belong to real numbers? Are there any numbers which do not belong to real numbers? Yes, there are numbers which do not belong to real numbers. For example, square root of minus 5. Square root of minus 5. This number is not a real number. We call this as complex numbers, right? So we have to use the ideology of complex numbers, which we usually discuss these complex numbers for A-level mathematics. Complex numbers. We call these numbers as complex numbers, and these numbers are not real. Square root of minus 5 is not a real number. The reason is you can't mark the square root of 5 in the number plane or number line. I hope you got these ideas. Especially which are very, very useful. Right? Now so when I draw this, I can draw like this. Whole numbers. This is a set of whole numbers. And here you have what? Integers. Right? You have integers. After that, you have rational numbers. And after that, you have real numbers. Irrational numbers are separately, right? Irrational numbers are like this. It is outside. It is outside the rational numbers, right? So here you can see the rational numbers, and here you can see irrational numbers. That is outside the rational numbers. Okay. Irrational numbers. Right. So I hope you got the idea about these number systems. So these are not much things to test in the question, but in the exam, but you should have good idea about this. You should have very good idea about this because these are very, very important things when it comes to mathematics. These are very, very important things when it comes to mathematics. Right. So we discuss about odd mass, and after that we discuss about number systems, and after that we are going to discuss areas of mathematics or algebra, right? There we are going to discuss some very simple things about algebra, right? Some simple things about algebra you should know easy. Basic algebra. Right? So very basic algebra, you know, a plus b is equal to b plus a. A into b is equal to b into a. So these are basic algebra. A plus b plus c is equal to a plus b plus c, right? So these are very simple things that we know actually these things we know, and which just give some idea about algebra. And there is another thing that, let's say you are multiplication addition. A B is equal to C. If A is an odd number and B also odd number, then the answer will be even number. Odd plus odd is equal to even. Right? Odd number plus odd number is equal to even. Even plus even number equal to even number. Even plus odd number is equal to odd number, right? So these are things that we should know under algebra. Odd plus odd. 1 plus 1 is equal to 2. 2 plus 2 is equal to 4. 2 plus 1 is equal to 3. So that is what odd plus odd is equal to even. Even plus even equal to even. Even plus odd equal to odd. So these are the things. And so what about the multiplication? Odd into odd. Odd. Even into even. What? Even. Even into odd. Even into odd. Then it will be right. Even into even. Even into even, you will get the even answer. Even number into odd number, you will still get even number. And odd into odd will be odd number. So these are basic algebra that you should know and which will be very, very useful sometimes when you do small calculations. Right? So those are the basic algebra things that you should know. After that, we are going to discuss about indices. Right? We are going to discuss about indices. What does it mean by indices? Indices. What does it mean by indices? If I write something like this, 2 to the power 3, what does it mean? If I write something like 2 to the power 3, what does it mean? It means this is multiplication of 2 3 times. Multiplication of 2 3 times. 2 to the power n, multiplication of 2 to n times. Multiplication of 2 n times. So here, you write a to the power b, we call this a as base. We call this a as base and this b as index. Right? We call this b as index and we call this a as a base. Right? So that means a has multiplied b times. A has multiplied b times. That is the idea of this a to the power b. So when we read it, we say that a to the power b, a to the power b, 2 to the power 3, 2 to the power n. So that is how we read this. And uh, there are some small laws that you need to know under indices. There are some laws related to indices.